Hello, hi. In this video, we're going to start a special type of general substitution known as homogeneous. So if you have not watched the previous three videos on general substitution, please watch that first before you watch it. Because homogeneous at the end of the day is a general substitution. It's a special type of substitution. So make sure you watch those first. So I'll directly go into the definition. What is homogeneous? So homogeneous is a differential equation. A first order homogeneous is a differential equation so that y prime can be written in terms of y over x. Y prime can be written in terms of y over x. So on the right hand side, you can write everything in terms of y over x. So y over x is always together. So y and x is not separated. In other words, y prime can be written as a function of y over x. It is helpful to remember that x over y can be written as 1 over y over x. So sometimes that is helpful. So let's look at our very special first simple example, and this is going to be quite simple. So here sometimes you have to do some manipulation or algebra before you can see that you can write in terms of y over x. So here I can distribute this x under each term, and if you distribute this x under each term, you end up with 1 plus y over x, right? And you can see that the right hand side is in terms of y over x. Excellent. Now I can do the substitution. So the substitution is always v equal to y over x. So that is the substitution. One thing to remember, before you take the derivative of both sides here, right? Before you take the derivative of both sides, you need to cross multiply. Because as it is y over x, you need to use quotient rule to take the derivative, and quotient rule is quite difficult. It makes things complicated, right? So let's cross multiply. If you cross multiply, you get y equal to vx. So that's very important. Always remember that you cross multiply before taking derivative. So for homogeneous, you always cross multiply before taking derivative. Excellent. Now you take the derivative of both sides. So on the left hand side is dy dx. The right hand side, remember v at the end of the day is a function of x because y is a function of x. So here this y is in fact is a function of x. So I have some function of x divided by x. So at the end of the day, v is a function of x, right? So let's take the derivative using the product rule. So dv dx times x plus, now I copy v times the derivative of x, which is 1. So I don't have to write that down. So in place of y prime, of course, the y prime is dy dx, right? So in place of y prime, I have to substitute my y prime. That's my y prime. So that goes in place of y prime. And in place of in place of y over x, I need to substitute v. So if I do all of that, let's see what I get. So I'm going to write it down below. So I end up with, so in place of dy dx, I have dv dx times x plus v equal to 1 plus v, because in place of y over x, I write v. So everything in terms of v and x, there is no y. You can cancel out the v from both sides, and I end up with a very, very simple differential equation. Oh, sorry. So I end up with, and this is in fact going to be a separable differential equation. So in this case, this is a separable. So this is separable. differential equation. So we already learned how to solve separable. Here v play the role of y. So v is the unknown function. So v play the role of y. So this is separable. So let's separate. So I can move this to the other side by reciprocal, right? I take the, so I get dv equal to 1 over x dx. Another way of thinking, you're basically multiplying, if you want, both side by dx over x. So you can cancel out dx and the x, you only have dv, and in this side it's just 1 over x dx, right? So now you take the integral. Here is the invisible one. So the integral of 1 dv is just v equal to, remember, we add c only one of the side. So I will add c on the right side. And the integral of 1 over x is ln of x plus c. So that's the constant of integration. That's the c. But that's not the answer. I have to substitute back the v. Remember, v is 1 over x. So I need to substitute v at the end. So I need to replace v by y over x equal to ln of x plus c. Multiply both sides by x. So I can actually write this explicitly, and that will be my general. In this case, it is actually an explicit solution. So not always you'll be able to solve for y in terms of x. So not always you're going to end up with explicit solution, but this is quite simple. So you can simply solve for y. So I actually get a explicit solution, but do not expect that every time. So that's it. That's my general solution.